Section 2.2, limit points. Definition 2.7. Let A be a subset of a topological space X. The point X in X is a limit point of A if X is so close to A that every neighborhood of X intersects A in some point other than X. Now, exercise 2.15 has to do with the finite complement topology. So I remind you what that is. Its open sets are the empty set and every set in the real numbers with a finite complement. Okay. So we're supposed to determine the set of limit points of the interval from 0 to 1, including its endpoints, in the finite complement topology on the real numbers. Now, I purposely didn't call that the closed interval from 0 to 1 because it's actually not a closed set in this topology. Okay. It turns out that actually every real number is a limit point of this interval in this topology. Every real number is a limit point of the interval from 0 to 1. So to prove that, I need to take any real number x and any neighborhood of x, so let u be a neighborhood of that point x. Okay. Well, then what that means is that u is open, since it's a neighborhood, and it's not empty, since it at least contains x, right? So, well, in this topology, if an open set is not empty, then it has to have a finite complement, right? It has to be really big. So let's call the complement A. It's x minus u, and it's got to be finite. Right? Good. Well, in order to show that x is a limit point, we have to make sure that u intersects this interval in some point other than x. Okay. So maybe we should look at the intersection of those two sets. The intersection of u and this interval from 0 to 1. Okay. Well, if A is the complement of u, then u is the complement of A. So I can replace u by x minus A and intersect that with my interval. And now I want to use a property from set theory to rewrite this a little bit. I can write it as the interval from 0 to 1 minus A intersect this interval. Okay. So you can think through why that works out. And my claim is that this is an infinite set. Okay. Why? Well, since the interval from 0 to 1 is certainly infinite. Right? It has an infinite number of points in it. And this thing that we're subtracting, A intersect interval from 0 to 1, well, that's finite, right? Because we said that A was finite, and when we intersect it with this interval, it can only get smaller, right? So we end up with a subset of a finite set, which is itself going to be finite. All right, well, now we're done, right? Because we just needed to make sure that this intersection contained some point other than x. But actually, it has infinitely many points in it, so it has a lot of things besides x. So thus, u intersect interval from 0 to 1 contains many points other than x. Hence, x is a limit point of our interval. Okay. And x was just an arbitrary real number, so we've shown that every real number is a limit point in this interval.